Hi everyone. I just want to let you know that I am now going to put together the video for chapter 5.3, example 3, and it's a little bit different than the last lesson, just a touch. You'll see why in a moment as we get started. So here we go. So we're trying something new here. I'm going to see if this video will play for you. It's a little entertaining. We'll see what happens.
A really cool thing. So get off your ass, let's do some math. Math. 3 minus 4 is...
-1.
That's right. And 6 times a billion is...
6 billion?
Nailed it. And 54 is a 45 more than what is the answer, Martha?
9.
No, it's 8.
No, it's 9.
Yes, I was testing you. It's 9. And that's a magic number.
Well, of course, we love math. And so what we're going to do now is we're going to go on and do example 3. And then we'll have an assignment at the end that I'll show you. But here we go. So you're going to need to have your unit circled out again, similar to the last exercise. So make sure you have that out. Pause the video if you don't and pull it out. And then I'm going to go on to the note. This would be the note that we would be using. Find all solutions of 2 sine x cosine x equals root 3 sine x on the interval of 0 to 2 pi. Now, this one is saying we're going to solve by factoring, which makes sense, but this is different in that the last time with examples 1 and 2, you had to put plus 2 pi n or plus n pi in order to do the problem. So, but on this one, you will be, got to make sure I get to the right pen because I've been using, been playing with these a little bit. You will need to know that we are using on the interval of 0 to 2 pi. And if you remember from the beginning of the year, interval of 0 to 2 pi means we are only going to look for the answers on the unit circle one time around. So 2 pi n will not be needed. Now, to review what this notation is, the bracket means 0 is included. And the parenthesis around the 2 pi means that 2 pi is not included. This is important because then you won't be listing 0 and 2 pi's answers twice because 0 and 2 pi have the same sine and cosine information. So that's why it's important to remember that. So let me erase all of this information so we can start solving this by factoring. Okay, I wonder if the old-fashioned way works. Yes! I love the old smart boards. Now they've given us dumb boards, but that's okay. There's some cool features for those too. So anyway, I'm going to write this down. 2, oops, got to get my pen back. 2 sine x cosine x equals root 3 sine x. So the first thing I'm going to do is I'm going to treat this like a quadratic. And I'm going to ask a question and give you a second to think about it so that I don't just give you the answer right away. But when it's a quadratic, what do we have to set the equation equal to? So think about that. when we're solving quadratics, we set the equations equal to 0. So for me to do that here, I would have to subtract root 3 sine x from each side. Oops, I must have done something there. Okay, so I'm subtracting that from both sides, okay? That gives us now 2 sine x cosine x minus root 3 sine x equals 0. Now we can do the factoring part. So now we can factor. So I'm just looking at this equation and figuring out what is common to both 2 sine x cosine x and negative root 3 sine x. Well, it is sine x. So I'm going to factor out a sine x. So sine x will come out here. And what's left inside? 2 cosine x minus root 3 equals 0. So now this is kind of where we get into the quadratic situation also, where we have two solutions. We have sine x equals 0 and 2 cosine x minus root 3 equals 0. So we have to solve for each one of those. This one is easy. Sine x equals 0 is easy, because then I'm going to be mindful of that. I'm going to go back and look at my unit circle. So for those who are needing to see my unit circle, I'm going to go back and I'm going to look, where is sine x equal to 0 on the interval of 0 to 2 pi. And hopefully you remember that sine is y, cosine is x. So where on the unit circle do I have a 0 for sine? Well, let's just pick a different color because we can. Okay, at the angle 0 degrees, sine equals 0, and at pi, sine equals 0. So I'm going to go back to my problem right here, and I'm going to list my angles here as 0 and pi. So those are two solutions possible for this. Okay. Now, this one, the next problem, we have to add root 3 to both sides and divide by 2. So that means cosine x equals root 3 over 2. So now I'm going to go back to the unit circle, and I'm going to look for root 3 over 2 as a positive. Well, cosine is positive, so cosine is positive in which quadrants? Quadrant 1, and you can't see it down here, but also quadrant 4. So 1 and 4. Okay, so I'm going to go back, and again, cosine is positive in quadrant 1 and 4, and we're looking for root 3 over 2. So I'm going to go look for my x value that's a root 3 over 2. That's at pi over 6. And since it's also in the fourth quadrant, I'm looking for 11 pi over 6. So I'm going to go back to that problem, and my answers for this portion are pi over 6 and 11 pi over 6. So the answers I'm looking for ultimately are these. Notice there's no plus n pi or no 2n pi. It's purely 0 and pi because of sine x equaling 0, and pi over 6 and 11 pi over 6 because cosine x equals root 3 over 2. So that's example 1. Now that we've finished this problem, let's go on to another one. It's a little trickier because of a different kind of factoring, which we've done all year, but some still struggle with this. So we essentially have a quadratic form of a sine equation here. And what I need to do is factor it. And using the method that we've used all year, I'm going to use the diamond method and get us started and then factor by grouping, and you'll see what that looks like. So if you remember, this is A. We don't have a number here, so that would be B, 1, because it's 1 times sine x. And this is C. So A, B, and C. So we draw our little diamond box. And it's A times C goes up here, so that's 2 times a negative 1, so negative 2. And then our B number goes in the bottom. So we have to come up with two numbers that multiply to a negative 2, but add up to a positive 1. So I'm going to just do some guessing. So I'm going to say negative 2 and 1. Well, negative 2 times 1 is negative 2, but negative 2 plus 1 is a negative 1. So that's not going to work, so we're going to erase that. Okay? Then I'm going to try, let's connect our boxes here again, making it a little bit of a mess. I'm going to try 2. Sorry about that. And negative 1. Well, 2 times negative 1 is a negative 2, and 2 times, 2 times negative 1 is negative 2, and 2 plus negative 1 is a positive 1. So we are good. So, okay. So that means now what I'm going to do is I'm going to be splitting up this middle term using those two numbers that we found. And I often like to use whatever the 2 goes into, so it's easier. So I'm going to list 2 sine squared x. And then I'm going to choose 2 plus 2 sine x minus the 1 sine x minus 1. So if you can see what I did here, this 2 is right here. And this negative 1 is right here. Okay. So now what I'm going to do is I'm going to put my imaginary, you see me do this in class all the time. I put an imaginary line and I say I'm breaking my equation in half. And then I'm going to factor each side. So what's common to both the 2 sine squared x and 2 sine x? 2 sine x. So I'm going to take a 2 sine x out. And what's left inside? Well, 2 sine x times sine x equals 2 sine squared x. And 2 sine x times 1 equals 2 sine x. So if I did this backwards, if I wanted to, I could go 2 sine x, and that would equal that. And I could go 2 sine x times 1, and that would equal that. So we don't need those marks. I'm just going to get rid of them, but that's to show you where we are. Okay. So I'm going to do the same thing on the other half. So what can I pull out of both? Well, a minus 1. So what does that leave inside? Well, a sine x plus 1. If you notice here, are the same. They can only be a factor once. So I'm going to write sine x plus 1 as 1 factor. Well, then I'm going to cross them out. And I'm going to look and see what is left. Well, I have 2 sine x, and I have a negative 1. So I'm going to write 2 sine x minus 1. All equals 0. Just like here, this also equals 0. Okay? So now those are the two factors that I have. So let's move to another screen so we can see them. We have sine x plus 1 and 2 sine x minus 1 equals 0. I'll go back and make sure I did that right. I want to make sure I wrote it down correctly. Sine x plus 1 and 2 sine x minus 1. Very good. Okay. So, we're back here. Now, again, just like our quadratic, we have to figure out what sine x plus 1 equals 0 and 2 sine x minus 1 equals 0. So if I subtract 1, we know that sine x is going to equal a negative 1. And we know by adding 1 to both sides and dividing by 2 that sine x is also going to equal 1/2. All right. So at this point, we need to go back to our unit circle. So go here. And again, we need to know where sine, oh darn, I keep doing that. Sine x equals negative 1 and where sine x equals 1/2. And that is on the interval. So again, we want to know what the answers are based on this entire circle one time around, from 0 all the way to 2 pi. So first of all, sine x equals negative 1 only happens in one spot. And I'm sorry, but it looks like my image has it cut off. Let's see if I can move it up a little. Yep, there we go. Okay. So if you look, sine x equals negative 1. Remember, sine is y. Sine x equals negative 1 down here at 3 pi over 2. And that's the only place that sine will be negative 1 because there are no other negative 1s on the unit circle for y. So we know it's 3 pi over 2. Okay? Now we've got to look for 1/2. Sine 1/2 will be, first of all, sine is positive and sine is y. So where is sine, in which quadrants is sine and y? Which ones are going to be positive? Well, in quadrant 1 and quadrant 2. So what am I looking for? I'm looking for where sine equals 1/2. Where's my y equal 1/2? Well, at pi over 6 and at 5 pi over 6. So my answers for this are pi over 6 and 5 pi over 6. So I'm going to go back to my problem. And sine is negative 1 at 3 pi over 2. Sine x is 1/2 at pi over 6 and 5 pi over 6. Now, if you remember, you don't need to put the plus pi in or the n pi. Well, first of all, n pi would only be for tangent and cotangent, but on sine, you wouldn't add the 2 pi in because we only want to know what's happening on an interval of 0 to 2 pi. So only one time around the circle, not into infinity and beyond, if you get what I'm saying. So that is that problem. So now what I want to do is I want to go to what we would be doing in our class. We would put this on Socrative. We're not going to put this on Socrative. And at this point, I would like you to pause the video and try to solve this one. I am pausing. Here we go. Pausing. All right, guess what? I'm not really pausing. You guys are going to pause the video. So I'm going to go through and I'm going to do exactly the same thing that I did in the last problem, and we'll see which answer you chose and whether or not it is correct. I hope you didn't cheat and go to the next slide. Actually, you can't do that. I'm controlling it by video. All right, good. Okay. So what I'm going to do is I'm going to do my little diamond, because this is something I do every problem. This is just me. It's how I solve. My A and my C, so negative 30. And my B, negative 1. Okay, I already figured it out. I know that it's going to be 6 times 5, but I have to figure out which one's negative. And because this is negative, I know the larger quantity has to be negative 6. So negative 6 and a positive 5. Negative 6 times 5 is negative 30. Negative 6 times, or negative 6 plus 5 is a negative 1. So now I'm going to do my breaking apart of my middle term. Okay, so okay, so I had momentary lapse of the Apple Pen failing on me, so we'll see how smooth this transition is. Anyway, so I want to start by, once again, breaking up those two, the middle term into two different terms. So, and I want to pick something that 2 will go into, which this negative 6 is perfect. So I'm going to say 2 tangent to the 4th minus 6 tan squared plus 5 tan squared x minus 15. Now, if you notice, it's not a quadratic, it's a quartic, but it factors in the same way. Because of this exponent, it's considered a quartic. So I'm still going to factor it the same way, and then I'll just have two terms that are squared. So I'm going to put my little imaginary line here and break it up. And I'm going to factor out what's common to this term and this term. So, and to me, that would be a 2 tangent squared x. So 2 tangent squared x. And what's left inside? 2 tangent squared times tangent squared would be the same as 2 tangent squared to the 4th. Then minus 3. Plus, well, I shouldn't say plus yet. Hang on. Let me get rid of this. Then I'm going to factor the second half of the equation. So that will be, what's common to both? Well, a positive 5 would be good for both. So I'm going to take out a 5. Positive 5. And then inside it's going to be tangent squared x minus 3. Because I did want these two, ultimately to be the same. And so now they are. So that means I have tangent squared x, oops, missing my x there, minus 3. So I can cross those out. And then what's left? 2 tangent squared x plus 5. I've got it. Tangent squared x will equal 3. So then tangent x will equal plus or minus root 3. With me? Okay. Over here, we are going to do 2 tangent squared x equals negative 5. And then we're going to do tangent squared x equals negative 5 over a root 2. Well, this one, I'm hoping you see that this particular problem is a problem. Because is there any way I'm going to get a negative out of a square root? No, it's an imaginary number. It is non-real. So right at this point, I'm going to go ahead and just cross this out because it's non-real. Okay? But over here, I can definitely find on the unit circle plus or minus root 3 for tangent. So let's go back to our unit circle. Ooh, got some erasing to do. Hang on. Okay. Gone. 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 Okay. Oops. And gone. All right. Now, this is a little different because unless you've written your tangents on your unit circle, you've got to remember that tangent is y over x. So you have to remember that tangent in letters is y over x. And with all of these, well, let's just do one. We know it needs to be root 3. So if I look at this one, I'm looking at pi over 3 right now. Root 3 over 2 over 1 over 2 is probably going to be what I'm looking for, because it would be root 3 over 2 over 1 over 2. Okay? And remember what I said about common denominators. If they have the same denominator, you can... Okay, you're an obnoxious little thing. You can cancel them out. So I'm going to cancel it out. That leaves me with just root 3 over 1. So that means this... Let's line it back up. Okay. This is actually your angle. So we know that pi over 3 is one of them. Okay. But now do we have that same combination, only maybe there's a negative to it in the second quadrant? Oh, yep. This one. Because it's going to still be the same format, it's just going to be negative. So it's 2 pi over 3. Do we have another combination? Because remember, we're doing this on an interval of 0 to 2 pi. That means we're going to have one for every quadrant on this particular one. So I've got to look for the similar combination over here. Oh, 4 pi over 3. And then the last one over here in the fourth quadrant is 5 pi over 3. So I'm going to go back and look at my multiple choice answers and see which one of them was correct. Oh, I made a big mistake here. I didn't read my directions. What do my directions say? 0 to pi. And rather than edit this whole video, you know I do brain farts in class all the time. So instead, I'm going to go back to my unit circle because I don't have any answers here that have 4 answers. So I'm going to go back to my unit circle. I should have read my directions. That's a lesson for all of you to pay attention to. And this time I'm going to get rid of 4 pi over 3 and 5 pi over 3 because I only need the top half of the circle because it asked for an interval of pi, 0 to pi, not 0 to 2 pi. That is me brain farting. Hopefully you all understand what I just did and forgive me for that so I don't have to go back and re-edit the video. So let's go back to our answers again. And let's see where we have pi over 3 and 2 pi over 3. Well, it is B. Now let's go look and see at the slide that I have here that says what the solution is. And let's hope that Mrs. Indahl actually did it right. So here we go. Ta-da! B is correct. So we're going to celebrate with this magic pen. Wow! Wow! Oh, see, that's magic. And now the others are going to disappear. Come on, disappear. So, I think that was kind of fun. But this one's, I like this one even better. And we need the smiley faces after all the brain farts I've done. So, okay. Last but not least, the dessert for the entire lesson. Homework. Yes. It is posted